Hello again. So now we're gonna do the first. We're gonna take advantage of the first consequence of our realization. Our realization that if we have an angle in a unit circle like this, or upon which we can superimpose a unit circle, that we can find the intersection of the terminal side of that angle with the unit circle, and we can use those xy coordinates as the sine and cosine. We're going to now take that as our new definition, okay, of the sine and cosine, okay? And so basically, we're going to redefine the sine of the angle and the cosine of the angle. The sine of the angle will be the y-coordinate of the intersection of the terminal side of the unit circle, of course assuming it to be in standard position, and the cosine of the angle being the x-coordinate of that intersection, okay? As we saw in our previous lecture. And as I hinted earlier, so in other words, let me be clear here. Our previous definition of the sine, in terms of the triangle's opposite side and hypotenuse side, will still be valid. It's, of course, as we saw in the previous lecture, it underlies this new definition, this new redefinition, if we want to put it that way. But this redefinition will be more useful to us going ahead, okay, for reasons that you're going to soon see, okay? And, but what I'm trying to say now is that I don't want you to let that previous conception of the sine go away. What I want you to think about is I want you to keep all these definitions and redefinitions in mind, because we might use one in one case and we might use another in another case, but you have to have this multi-layered view of these things to really appreciate them and to, yeah. So now, so as mentioned before, let's say I have here, okay, an xy axis like this. I can now take a unit circle. Let's say that this is the initial side of some angle, and let's say that this is the terminal side of that angle. Look at this angle here. That's more than 90 degrees. You could never fit that in a right triangle. But because of this new definition of the sine and cosine of the angle, and because this is a unit circle, this terminal side will have an intersection, let's say xy for this purposes in general. And so let's say this angle measures phi, okay? Then from our new definition, we knew that the sine of this phi, okay, will equal to that y coordinate. And we know that the cosine of this phi, whatever this phi is, will be the x coordinate, okay? So in other words, this redefinition of the sine and cosine, in terms of the intersection of the terminal side of an angle with the unit circle, again, assuming that the angle is in standard position, allows us to find the sine and cosine of angles that we could not have conceived of in the original right triangle formulation, because we could never fit this angle inside of a right triangle. Okay? Because remember, the three angles in a triangle have to add up to 180, and if you have any right triangle, let's say like this, okay? If I already have 90 degrees there, then these two angles have to add up to 90 in order for them to be able to be inside of this triangle. And so an angle like phi that's so much larger could never be placed here, because it would already make this sum go beyond 180. So in other words, our previous definition would not have permitted this identification of the sine and the cosine. But our new definition does permit that. And that's, so in other words, what we're doing is this new definition of the sine and cosine allows us to expand the domain, the possible input values of the sine looked at as a function and of the cosine looked at as a function. Okay? Let me also point out something else. Another consequence. So number one, we already have one consequence. The domain of the sine and cosine, and consequently of the tangent, has been enlarged. We can now find the sine, cosine, and tangent for any angle from 0 to 2 pi. Okay? And in fact, beyond that, but we'll get to that later. Okay? That's number one. Number two, I want you to look at this diagram for a moment, and I want you to notice something. In this quadrant, okay, the x coordinates and the y coordinates are both positive, right? The y is positive and the x is positive. So the sine and cosine here are positive. But because of our new definition of the sine and cosine, or our redefinition of it, as the x and y coordinates of the x and y coordinates of the intersection of the terminal side of the angle with the unit circle, I can see that, there will also be, of course, as we saw in that diagram over there for phi, there will also be sines and cosines over here if the terminal side is here. But over here in this quadrant, okay, we're going to label these quadrants 1, 2, 3, and 4. You can see that in quadrant 2, x is negative, y is positive. So therefore, for example, the cosines are negative here in quadrant 2, and the sines are positive. By the same reasoning, I'm sure you're already aware that here in quadrant 3, since the x's are all negative, the cosines are negative, the y's are negative, so the sines are negative. And in the quadrant 4, x is positive, so the cosines are positive, and the y's are negative, so the sines are negative. So that's another consequence, okay? In other words, when we were looking at the sines and cosines originally, solely in terms of the relationships between the side lengths of a right triangle, the sine, the cosine, the tangent were always positive numbers. But now, as a result of our redefinition of the sine, cosine, and tangent, we're going to have the sine taking on positive and negative values. Okay? Okay. And so these are the first consequences of this redefinition, okay? And let me see. I hope you all have enjoyed this, and I'll see you again soon. Thank you.